I would like to introduce this morning the Senior Vice President of Engineering from Cirrus Design, Pat Waddick. Pat, come on out, please. Thank you. Well, help me welcome him.
Thank you. Well, thank you, Ted. I appreciate that great introduction. I'd like to thank PTC User and PTC for inviting Cirrus to be part of this great event. I'd also like to thank the team back in Duluth and Mark Hendrickson, who will help us a little bit out today. I also want to thank you guys for taking time out of your busy schedules to come to the conference and see all this good stuff. Long Beach is a pretty exciting place to be. It has a very rich aviation background. You had guys like Don Douglas start a little airplane company down the road, Douglas Aircraft. You might have heard of it. He had a pretty unique team of people that he was mentoring. He had an engineering draftsman, a gentleman by the name of Jack Northrup. I think everybody's familiar with Jack. He had another guy by the name of Dutch Kindleberger. Now, Dutch went on to be, he was a project engineer for Douglas, but he went on to be the president of North American Aviation and probably led one of the most inspirational aircraft design projects that we know of, which was the P-51 Mustang. You had guys like Kelly Johnson at Lockheed Skunk Works, Howard Hughes, of course, who embodied the entrepreneurial spirit and passion of aviation flying over the skies of Los Angeles. So it's really fitting to be here. This is a place where vision and passion and design innovation really is ruled the day. Now, these same qualities have really fueled Cirrus Design to its success, and really one of the factors that led to us building one of the world's best-selling airplanes, the SR-22 aircraft. Now, we achieved these things through high expectations on ourselves, on the people around us, to do better as it relates to things like safety, performance, cost, etc. So I look forward to sharing our journey with you and how these high expectations really raised the bar, not only for people at Cirrus Design, but really an industry as a whole. See, doing good design is our responsibility. The people in the room, myself, you, the people that you interface every day, you have the highest influence on customer value. It's really designed in, and I think we see that every day. So if the foundation of achieving high customer value is vision, then it's got to be fueled by passion, knowledge, and the tools that make it easier. Now, we're going to spend a couple of days here together learning and sharing and talking about the tools of the future, but these tools really are only as good as our expectations for customer value and how we drive that every day in what we do. So let's take a little journey, talk about the Cirrus Design story, and hopefully as we're talking about this, it adds a little bit of inspiration to you. Now, I want to talk a little bit about our vision and how we got there. Now, you're probably not ready for something as thoroughly complicated as this, but Alan, our co-founder, years ago summed up our vision in pretty much three simple words. Number one, it's got to be fun. Fun is kind of the nutrition for keeping yourself going every day. If we're not having fun, then it just isn't worthwhile. But it had to be meaningful. We wanted to change the world. We wanted to leave an imprint on the world that said we weren't just there to have fun and to do lots of other things. We wanted to actually make people's lives different. We wanted to change the way they lived, the way they interacted as a family, as a business perhaps. The last one, of course, is making money. Now, at the time, I think we threw this last one in there just to make sure that we could do those first two. But as we got older and we had more children and more expenses, it started to make a little bit more sense. So how do we change the world? Well, there's an old adage many of you are probably familiar with, that an airplane is nothing more than a bunch of engineering compromises flying in close formation. So achieving higher customer value and doing it better, well, it must mean that we're doing these compromises better than anybody else. So let's talk a little bit about how we did that. I want to talk about a baseline, because if we're going to talk about doing it better, we have to look back some years and look at what we were dealing with back in the 70s, 80s, maybe as far back as the 60s. Now, this is a pretty conventional aircraft that you're seeing here. The outcome of this accident probably wasn't so great. The accident rate back in the 70s was about 18 per 100,000 hours flown. So that meant if you're a typical general aviation pilot and you were going to fly maybe 5 to 10,000 hours in your lifetime, you had a reasonable probability of being involved in an accident like this. So how did this happen? Well, I think a couple of different factors. Number one, safety regulations. These were really just developing at the time. Secondarily, there were really some serious limitations on technology. You had the technology to make pretty nice airframes, but the systems that could help keep people safe weren't necessarily there. So let's talk about a couple of enabling technologies. Number one, I think one that really changed things significantly for everybody here over the last 20 years is low-cost computing. Low-cost computing led to advanced avionics, electrical systems, and of course the tools that we use every day for design work. Now you also had some new materials coming out, tougher epoxy resins, fiberglass materials, and actually the commercialization of many of these composite materials really made it possible for Cirrus to harness these in aircraft design at a low cost point. Now the last item is a change in value expectation. In the late 80s and the early 90s, there's something called the home-built movement. And a lot of people were buying kits or they were getting plans and they were building aircraft in their garage. So you'd go to an air show and you'd look at these different home-built aircraft and you would all of a sudden see, hey, that's a really nice airplane. That has great avionics, it has great systems. Why can't I get that in my production airplane? So consequently, there was this increase in overall expectation within the marketplace. Now, the last item was some changes in our product liability laws with the General Aviation Revitalization Act. All of these factors together really brought about a significant change in general aviation over the last 10 years, and Cirrus was a big part of that. So what it led us to is what we'll call technically advanced aircraft. That's kind of where we're at today. The Cirrus story is really embedded in that. If we look at the safety record today, it's almost a third of what it was 20 years ago or so. That's a big change over that period of time. Some of the factors, of course, we talked about enabling technologies, huge factor in that, but you also have a safety-minded culture. I don't think today we could open up a magazine, Time magazine, any other magazine, and not see an ad from an automotive company talking about how important safety is to you. So that also has changed our expectation greatly. So now this example on safety is just kind of one dichotomy of where we were just in the last 10 to 15 years and where we've come over that time. So let's talk about this a little bit. You know, we can do good things like in that picture back there, which, by the way, I should say, that's an SR-20. Now, that was an SR-20 in Europe that was maneuvering too close to some ground wires, and they ended up, as you saw, going into some trees and then landing on top of a hay bale. All of those people walked away. So we can do a lot, even in a crash-worthiness sense, to save people's lives, but it goes even further than that. There's more.
Everybody in aviation has been intrigued by the development of the Cirrus airplane, the plane with its own parachute. If the engine of a Cirrus conked out, this chute promised to lower the plane and its occupants safely to the ground. Carefully orchestrated tests were successful, but now there has been a real-life test of the Cirrus SR-22. One of them did lose power over Denton County, Texas, and the parachute was deployed and the Cirrus came down in trees. The plane did remain largely intact and the pilot walked away from it.
That's pretty inspiring. You know, I've probably listened to that audio clip 100 times in the last 10 years, and I still get the hair rising up on the back of my neck. That's making a difference. That's having a vision, having expectation and doing something with it where it's really changing the world. So let's talk a little bit about the Cirrus journey. Now, this is a story that goes from literally a barn to a jet over the last 15, 20 years or so. This growth has taken us from an entry level in the marketplace, an entry level point in the marketplace, all the way through to having a 30% market share. And really today we compete head to head with a company called Cessna, which most of you have probably heard about. We've had the opportunity to do a lot of fun designs over the years and really just keep increasing our expectations for what we should be doing next. So this growth has taken us to delivering over 4,000 airplanes in the last 10 years. And today I'm thankful to say we're 1,250 employees strong that make this work every day. Now we'll talk a little bit later about how we put them together, because it's really a unique process that makes this happen on a daily basis. Now, we're up in primarily in Duluth, Minnesota, and we have some great facilities up there. We take care of our final assembly for the aircraft, flight test, delivery to the customers. We also do all of our product development up in Duluth, Minnesota. But we also make all of our composite parts. Now, our aircraft are built with composites, and we'll talk more about that. We make those in Grand Forks, North Dakota. So we truck all of those parts over to Duluth. Now, it wasn't really always this nice. Before these days, we had, of course, the hangars in Baraboo, Wisconsin. And this was back in the days when we were making one of our first airplanes, the VK-30 aircraft. And as I mentioned, before that, well, it was a barn somewhere in central Wisconsin area. So it's really been a journey that's led us to appreciate what we have and how we do it. And being that we're talking about kind of the early days, let's talk a little bit about the VK-30 aircraft. Now, the VK-30 was a concept that was born in about the late 1970s by Alan and his roommate, Jeff Viken, when they were at Ripon College. And they were flying Cessnas, and they were flying lots of other aircraft, and they asked themselves really the same question many people were asking: where's the value? So we don't see it. Let's make it. Let's start our own company. So they did. Now, Jeff went over to George Washington University to work on natural laminar flow airfoils, and the brothers Alan and Dale went to the barn. And as Jeff was designing the aerodynamics of the airplane, Alan and Dale were busy in the barn putting it together. They were the salad days, I guess, as you call them. That eventually led us to flying our first VK-30 prototype in 1988. And during the course of time, we produced about 50 of these airplanes. Now, going back to those days in the barn, and I call them rather humble beginnings, you saw Dale up there in the opening sequence, and he talked about how we designed the SR-20, putting 4 chairs out and tape measures. In fact, Dale, you can always find him with a tape measure in his pocket because it's a pretty pragmatic way of designing airplanes. But there's Dale sizing up the first VK-30 Master. So I realized that it really wasn't the SR-20 days that this started. As we were going through the archives, I found out that Dale was actually doing this far earlier. Now, the original days of 3D modeling really consisted of how we made the tools. Often we didn't know how it was going to look until we took all of these 2D sections and we put them down on the ground, and then we started shaping it so we could see the tool. At that point, then we would possibly make some changes, and then we would pull molds off of those to make the actual component parts. And that's what you see here. This is one of actually our early VK-30 kit aircraft before we kitted up and put it out to the customer. Now, this was a fairly large airplane. In fact, this was one of the largest kit aircraft in the marketplace. And we'll see it flying in a moment here, but you'll see that it really is a complex, high-performance airplane for that kind of marketplace. And of course, we took that all the way through first prototype assembly. So let's take a closer look. The VK-30, and this is important, by the way, because this aircraft, if you look at the jet behind me, it really has some similar qualities to what we see with the VK-30, just less that propeller in the back. It was a 4 to 5 seat aircraft. It was a pusher configuration. As you can see, really has some great improvements in aesthetics for an airplane when you put the propeller in the back. But it's also great for low noise, comfort, great visibility, There's just lots of good factors. It's easy to get in and out of. Some complications as well. Engine was mounted in the middle of the fuselage, had a fairly lengthy drive line. We had a dry fluid clutch to make sure that we could dampen out possible torsional resonance in the drive line. It was the first time that we were using some of the more advanced materials. So we were using vinyl ester resins and some epoxies and fiberglass to put these together. This was really one of the early days that we started using CAD as well. Back in those days, I think we were spending about 5-10 minutes waiting for AutoCAD to regenerate. Probably some of you remember those days. But we also did all of our stress by hand. Today we use MathCAD. Back then we did it by hand, but we also used a lot of Fortran programs to do that. Now this VK-30 aircraft really was a stepping stone. It helped us learn a lot about designing complex airplanes, but it also gave us more worldwide exposure. And that led to the ST-50 project. The ST-50 was about a 20% larger version pusher configuration aircraft than the VK-30. It was all composite. It was designed to be pressurized. It was a turboprop aircraft, and really was there to be competing in the production certified segment for business general aviation. So let's take a closer look. Back then, this was, I think, the early 1990s. This was the first time that we started using ProEngineer. Show of hands, who here remember sitting in front of a Silicon Graphics machine? Anybody? Okay, pretty good show of hands. So you guys remember what those days, that was pretty exciting. So when you went from waiting 5 to 10 minutes for AutoCAD to regenerate, and then you were able to start modeling these things in 3D, that was fantastic. Now, being an aviation company, for those who remember, the SGI units had a great flight simulator game on it. If you came to Cirrus at about 10 o'clock at night, you'd probably find us flying the flight simulator game. So we transitioned to, from that stage, really to look at some of the advanced aerodynamics of that. With the day and age of computing power, we were able to use really the first use for Cirrus of computational fluid dynamics. That gave us an ability to start iterating the aerodynamic design of both the wing and the fuselage before we actually committed to firm tooling. And then that led, of course, to our prototype aircraft. Now, this project spanned from 1992 to 1995, and our part was really just to do the advanced design development of this first proof of concept aircraft, and then it transferred to an Israeli-European company. Unfortunately, they didn't make it, but what did happen was it was another great stepping stone for Cirrus in learning about more complex systems in the aircraft, really maturing our design technology of how we designed airplanes. So since we're talking about the advent of ProEngineer for Cirrus design, let's talk just briefly about why we chose that at the time. I think today's demands are certainly very different than they were back then. I think back then we were mostly just excited to be able to see something in 3 dimensions. Parametric capability was something that was pretty important. I talked about iteration.